Question 10 is a scenario where a car is towing a trailer. So if we do a quick sketch of what's going on. We've got the car out in front and it's connected by a light inextensible string, which is the tow rope, to the trailer over here. And the car is 1,400 kilograms and the mass of the trailer is 700 kilograms. And it says that we've got the resistance to the motion is acting on the car is 630 newtons. So that's 630 newtons acting on the car and 280 newtons acting on the trailer. It also says that the driving force on the car due to its engine is 2,380 newtons. Now, as well as this, we also know there's going to be a tension acting in the string here, in the rope. And the first question is to find the acceleration of the car. So it's moving in this direction, so there's my acceleration. So for the whole system, we're looking at the whole thing, and we're going to use F equals ma. The resultant force is equal to the mass times the acceleration. So if we resolve to the right, we've got 2,380 acting to the right, but I need to take away 630 and take away 280, as they are both acting to the left. And that will be equal to the mass, well, the whole mass is going to be 700 plus 1,400, which is 2,100, times the acceleration, which is what I'm trying to find. Well, if I do this calculation, I get 1,470, which is then equal to 2,100 multiplied by a, and therefore I just divide by 2,100 and I get that the acceleration is equal to 0.7 meters per second squared. Part B then wants me to find the tension in the tow rope. So to do this, all I'm going to do is focus only on the trailer. So imagine I've cut off my diagram and I'm focusing only on this section. Well, if we have a look then, I'm going to draw out what I'm focusing on. I've got 700 kilograms of my trailer. Then the resistance force is 280 newtons. Acting to the right, we've got the tension. We've cut that rope off, so we're exposing that tension that's acting in the rope. But we do know that the trailer is moving at an acceleration of 0.7 meters per second squared. So what I'm going to do is, for this trailer, I'm going to resolve to the right, and I'm going to use the resultant force is equal to the mass times the acceleration. Well, to the right, I've got the tension. I need to take away 280 acting to the left. That will equal 700 multiplied by the acceleration 0.7. If I resolve that, I'm going to get that the tension is equal to 770 newtons. The next bit of the question is asking me about when the rope breaks. So it says, the car and trailer are moving at 12 meters per second and the tow rope breaks. Assuming that the driving force on the car and the resistances to motion are unchanged, find the distance moved by the car in the first 4 seconds. Well, when the tow rope breaks, that means that the tension will disappear because the rope goes slack, there's no more tension. So if I just focus only on the car, 1,400 kilograms, we're saying that the driving force remains the same, so it's still going at 2,380 newtons driving force, and the resistance force is staying the same at 630 newtons. And I want to calculate what is going to be the acceleration, is what I want to try and find here. So, here, my acceleration. I'm going to do the same as I did in part B. I'm going to resolve to the right, and I know that the resultant force is equal to the mass times the acceleration. Well, To the right, I've got 2,380. Take away 630, acting to the left, equal to 1,400 multiplied by the acceleration. Well, this is 1,750, so 1,400A is equal to that. And therefore I can divide by 1,400 to get that the acceleration is equal to 1.25 meters per second squared. Now I'm not finished there because the question is the distance moved by the car. So let's use Suvat and write what we know. The distance is what I'm trying to find. The initial velocity is equal to 12 meters per second. It tells me that in the question that they were moving at 12 meters per second. The final velocity, I don't know. The acceleration is 1.25, we've just worked that out. And the time is 4 seconds because we're asked for the first 4 seconds how far it moves. And therefore I can use S equals ut plus a half at squared. If you sub all those numbers in, you will get that S is equal to 58 meters. And then finally, the last part of the question is saying, state how you have used the modelling assumption that the tow rope is inextensible. And all that means, part D, not I, is that the tension is constant throughout. So if it wasn't inextensible, we wouldn't have been able to work out that tension here in the tow rope. However, it is inextensible, so therefore the tension will be constant throughout the whole of the tow rope.